Hello, welcome back to Introduction to Python. So in the last class, we basically discussed briefly over the basic data structures in Python. Right? We paid a lot of attention to lists. We talked about what the mutability and immutability of lists look like. How do you insert something into a list? How do you index into a list? Today, what we are going to do is we are going to take a slide shift, and we will be talking about how to organize your code in Python. Right. So we will be talking about things like modules, how the Python code is executed, things like packages, virtual environment management, and so on. Right. Once again, so after we have covered that stuff, we will come back to the basic data structures. So we will be discussing the remaining data structures like tuples, sets, and dictionaries. All right. Now, once again, if you are new to this stream, we are doing this live Python series in which we start from the very basics of Python, and the end goal is to make a complete application using Django, a complete to-do application using Django, and actually deploy it to Heroku. All right, so you will be able to see the previous lectures. If you just go to the video description, there will be a link to any of the previous lectures. All right. So without further ado, let us begin with today's class. All right. So yes, I hope that you can see my screen. Perfect. Cool. So let me quickly exit everything and let me open these things once again. So what I'm going to do is, first of all, I'm going to open a very basic text editor. Right. So as we remember in the first class, we started by coding in a REPL, right, an online code editor. But today, after that, we have moved to a local setting, right? We have moved to a local development environment. So I'm going to open my code editor, which will be VS Code. You can use any code editor if you that you want. You can use something like Notepad++ or VS Code or Atom or Sublime Text or even Vim, Emacs, PyCharm, whatever floats your boat, right? So, but please make sure that it is a code editor. It is not just a text editor or a word processor. Please do not use anything like MS Code, and please do not use anything like Notepad, the vanilla Notepad. All right. So let me quickly open VS Code over here. So I've just opened VS Code over here. Let me also do one thing. Let me open the terminal. So irrespective of whether you are on Mac OS, Windows, or Linux, you will have a terminal. Right? So if you just open this terminal, I'll just open this on the side over here, and I'll just open the VS Code on the left over here. Let me resize the windows quickly. Cool. Now what I'm going to do is, first of all, I'm going to create a new folder for today's class. So let me create a new folder. How do we create a new folder in terminal? We do mkdir, which stands for make directory. So let me quickly zoom in over here. We do mkdir, which stands for make directory, and then we enter the directory's name. So we can do project organization. Right. So now if I do ls, I will see that a folder has been created with the name project organization. And to go inside this folder, I can do cd project organization. Right. So now we are inside this folder, and currently this folder is empty. All right. So let me quickly go over here in the VS Code and let me quickly create a new file. Let me create a new file, and let me create a very simple file, and let me save this file inside this folder. So I am in the home directory over here. Let me go to this folder, project organization, and let me save this file as example.py. All right, perfect. So let us quickly ignore these warnings that are coming over here. Let us quickly close as well. Let us go back to the example.py, and let us write a very simple hello world program over here. So I'm just going to write print hello world. Right. Now, how do we really execute this? How do we really execute this code using our terminal? We will have to. So I'm in this project organization folder. If I try to list the directory, so once again, ls stands for list directory. If I list the directory now, I will see that yes, there is a file called example.py in my directory. Right. Over here as well, you can see that. So currently I don't have any folders open, but this example.py we saved in my home folder, and inside that this directory called project organization. To execute this, I will run a command that will look something like this: python3 followed by the name of the file. Right? So python3 followed by the name of the file, in this case example.py. Now when I execute this, we will get a hello world back. Now depending on your system, whether you have Python correctly set up or not, you might get an error or you might get a result back. If you are getting an error, then please make sure that you have downloaded the latest version of Python from python.org. All right. So in the first class itself, we discussed how to set up Python. We shared some resources. There was a very nice link that we had shared, which allowed you to install Python on any operating system that you are working on. So please, if you are not familiar with how to install Python, please go to that first video and follow it along. All right. Cool. Now, once we have Python installed, we have to kind of figure out where the Python is actually installed. Because as we know, there are multiple versions of Python, right? There's Python 2, there's Python 3. Inside Python 3 as well, there are multiple versions. For example, someone might be using Python 3.5, someone might have Python 3.7 installed, and so on. I suppose the latest version currently is Python 3.8. Okay. So since you might have multiple versions of Python installed on your system, it makes sense to know which Python you're currently running in. All right. So there are two ways of doing that. The first way is in the code, you can do something like the following. You can import the sys module, you can import the system module, and then you can print the sys.version. So this variable sys.version, this stores the current version of the Python interpreter that we are running. So if I go over here and I run the example file again, I suppose I did not save it. Let me really save that and run the example file again. We will see that I am currently running the Python version 3.8.2, right? The other way I can do is I can come over here and write Python 3 minus version. Right? If I execute this, I will get the Python version once again as the output. All right. Now this tells me what Python version I am using. If I want to find where this Python file is located, right, where this actual executable is located, I can use the which command. Right. So the which, not that magic doing which. This is the which command, and I can type the name of the command. Right. So I can type the name of the executable that I want to find. So which Python 3. This will give me the location of this Python 3 file. So I currently know that this Python 3 file lives in user bin Python 3. All right. Perfect. So depending on what your program is, depending on what your project is about, you might want to use different versions of Python, right? So we will come in a second to how to switch between different versions of Python, how to make sure that we have the dependencies managed in a nice way. But before that, let us go back to our code and let us quickly see how Python really executes these files, right? So once again, we are back in this file. We are back in this file over here. Let us delete everything and let us create several print statements. So I will create print. This is statement 1. Statement 1. And let me copy this several more times. So this is statement 2, statement 3, statement 4, statement 5. Right. So if I execute this file, you all know what is going to happen. If I very quickly execute this file, Python 3, example.py, you all know what is going to happen. All these statements will be printed out from top to bottom. Statement 1, statement 2, 3, 4, and 5. Unlike most programming languages, right, unlike most compiled programming languages, Python strictly executes the file in a top-to-down manner. Right? So Python will execute this line, followed by this line, followed by this line. And it doesn't really matter what kind of code you have in the file. Python will always read the file from top to bottom and it will start executing things. All right. For example, I could come over here after print statement 5, I could define a function. I could define a function, and inside this function, I could do print inside function. Right. So if I do this, and once again, after that, I can say print statement 6. If I execute this file, what do you think the output will be? So Python will start executing the files. Right? Python will start executing the files. It will start from line 1. It will print statement 1, statement 2, statement 3, statement 4, statement 5. What really happens when Python touches this line? Python will execute this line as well. So Python will execute this line. However, this inside function, this print statement will not be executed. The reason is that when Python is executing this line, this is a line that declares a function. So what Python is going to do, it is going to read this function definition and it is going to create a variable in its memory. It is going to create a variable called foo, and that foo variable will hold a pointer to a function. Okay. So after this, we will print the statement 6. So actually what you will see printed out is statement 1, 2, 3, 4, 5, and 6. But in fact, Python also did execute this line. When it executed this line, it just declared the function. It did not call the function. Right? So if I just run this code very quickly, we will see that yes, 1 to 6 are printed out and the function has not been called. If I want to call the function, I have to explicitly call it. I can say something like foo, and I can call this function using these curly parentheses notation. Now when I run this code, the statements 1 to 6 will be printed out, and after that, this function foo will be called. So after that, the inside function will be printed out. Okay. So this is very simple. Python simply reads your file from top to bottom and starts executing statements. Whenever there's a statement like a definition, right, a function definition, or whenever there's a statement like a class declaration, so class spam, and we might have some things over here. So print hello. Right. So all these things, whenever Python hits line 7 and tries to execute this line, it will not in fact execute this inside line as well. Python will not execute this line. It will just store this. It will just create a class and store that in the variable spam. That is what will happen when it executes the 7th line. All right. Perfect. Vidhan is saying that the code is not properly visible. Can you please change the background theme? So the current theme for the entire thing is dark. So I hope that it is clear to you guys, but let me quickly zoom in. Perhaps this is a little better. Right? Yes, can you guys see the screen better now? Perfect. Ravinder is asking, we could add an error in function foo, which would tell it run top to bottom. Not really. So Ravinder, if something bad happens over here, for example, if I try to do something like print 1 divided by 0. Right? Now in Python, let me quickly open Python terminal over here. In Python, if we try to do 1 divided by 0, we will get an error back. Right? The error is 0 division error. All right. Now, if I try to do something like print 1 by 0 inside this function foo, notice that this line will not be executed unless I call this function. This line will not be executed unless I call this function. So if I have code that just looks like this, this faulty line is inside the function, but the function is not being called. Right? Notice that this line is commented, the function is not being called. This program will run just fine. And I will see 1, 2, 3, 4, 5, 6. I forgot to save it, I suppose. We will see 1, 2, 3, 4, 5, 6 printed out. Right? Now, if I actually try to call this function, that is when I will get an error. Right? So 1, 2, 3, 4, 5 will be printed out. Then 6 will be printed out. And then when I execute foo, the Python interpreter will go inside this function. It will try to calculate this line, and which will result in an error. So I see after the 6 statement has printed, I was calling the foo function, and inside the foo function, I got a 0 division error. All right. When you actually declare this function, this line will not be executed. So if there is an error in this line, that's perfectly fine. As long as the error is not syntactical, as long as the error is a runtime error, this declaration will work just fine. The error will happen when you actually call the function. Okay. Perfect. So let me quickly zoom out over here in the terminal, perhaps, so that this is a little more visible. All right. So the key thing to remember over here is Python executes files from top to bottom. Let's move on then. Now let us move on from one file to multiple files. Okay. So suppose that I create one more file over here. Let me create one more file over here. Let me say this is some module.py. All right. So if I do a listing of my directory over here in the terminal, we will see that we have two files now, the example.py that we already had and the sum_module.py that we have just created. Let me come over here inside the sum_module.py. Let me include a print statement inside some module module.py. All right, perfect. Now let me try to import this line in example.py. So let me remove some of the code, and let me come over here and let me import some module. Right? Let me import some module and let us see what really happens. Right? When we try to execute this code, what Python will do is So let us say that we are going to execute example.py. So Python will start reading this file from top to bottom. It will say, okay, I have to import some module. As soon as Python hits this line, it will look for this file and it will start executing this file from top to bottom. So the first thing that will be printed out will be this statement, right, inside some module.py. Once this file has been completed, once this file has entirely been read out, Python will come back to this location and it will print the statement 1. right? So the expected output here is first this gets printed out, then this statement 1 gets printed out, and as we see, that is exactly what happens. Right? Inside some module gets printed out first, and statement 1 gets printed out next. All right. Now, once again, unlike most languages in which all your import statements should be at the very top, right? Whatever libraries you are importing, they should be at the very top. That is not true in Python. You can take this import statement and you can move it anywhere. So I can take this import statement and move it under this statement as well. So now when Python runs my code, Python will first encounter this line and it will print statement 1. After that, it will go to import the module and print this particular code over here. Is that clear? Yes, so let us quickly run this now. Now we see that the things have reversed. I forgot to save it, I suppose. Yes, now the things have reversed. Right? So we print the statement 1 first and then we import the module. And when we import the module, this line gets printed out. I hope that is clear. Perfect. So there is one thing that we basically learned over here, that whenever we are splitting our code into multiple modules, we should not really execute the code directly. We should not really execute the code directly. Over here, there could be some code that deletes a file. If I'm importing someone else's code, I don't want that code to execute directly. I want that code to be declared so that I can call that code whenever I want to. Right? I don't want to call that code directly. For that, Python provides something else. Right? So currently, if I let me try to print out a new variable over here. So let me just remove anything and let me just print out a variable called name. Right? So the syntax over here is underscore underscore name underscore underscore. Right? So there's double underscore. And in Python, you can also call this as Dunder values. Right? So this is Dunder name. The way you would pronounce this is you would say Dunder name. And this just stands for double underscore name double underscore. This is a convention that Python uses for a lot of different variables. All right, so you will be seeing a lot of underscores in Python code. All right, let us quickly try to execute example.py and let us see what we get. When we execute example.py, it says that the name variable holds this value underscore underscore main underscore underscore. All right, and that is how you distinguish whether you are being executed or whether you are being imported, right? So let me come over here. Let me quickly go to this module and let me also include the same line over here. Print Dunder name, right? So I'm in some module. I'm printing the Dunder name in some module. I'm also printing the Dunder name in example.py. And let me quickly import some module from that file. So what do we expect to see? We will go inside some module. And we will execute this line, print Dunder name. Right? Then we will come and execute this line. But the value of Dunder name for both these files will be different. Right? The value when we are in example.py, that will be underscore underscore main. But when we are in some module.py, the value of the Dunder name variable will be different. Let us quickly see what we actually get. So we get over here some module. Right? We get over here some module. Basically, whenever Python imports a module, whenever you import a module like this, in the module, the Dunder name variable will be the module name. So for example, in this case, some module. On the other hand, if you're directly executing the module, if you're directly executing that file, then the name will be Dunder main. All right. So for example, in this example.py, I was importing the some module. So the Dunder name was some module. But if I come over here and I directly execute some module.py, then in this function, in this file, the Dunder name will be Dunder main itself. Right? It will be Dunder main and not some module. Is that clear? And that is basically how we can distinguish between when our code is being imported versus when our code is directly being executed. All right. Rohit is asking, are these constants? No, Rohit, in Python, nothing is a constant. I could totally come over here and try to change the value. So I could say Dunder name equals to hello. Python allows that. Right? I can now print this value of Dunder name and it will print out hello for me. Right? So main is printed, then hello is printed. So in Python, everything is changeable. All right. Dhruv is asking, does import also lead to execution of module? So that's a good question, Dhruv. Yes, whenever you import a module, you are actually executing it from top to bottom. Whenever you import some module, You're actually executing that module from top to bottom, which is why whenever you write a Python module, it is never a good idea to have executable code. The way we actually do things is we define functions, right? We define our variables, we define our functions over here. So I can say def foo and print inside foo, right? But I will not call foo. I will not call foo over here, right? So that when I import this module, only this function gets declared. The function does not get executed. If I want to execute that function, I can come over here and I can say some module dot foo. All right. So if I do this, then I will be calling some module.foo explicitly. By just importing this module, Python will execute this module from top to bottom, but this function will not be called. This function will just be declared. Is that clear? Yes. So once again, if I quickly save both these files and run them, then we will see. Interesting. Nothing really happened. Oh, I ran some module, my bad. So if I just run some module, then I should not get any output. Right? I should not get any output. But when I run example.py will actually import this module, this function will get declared, and then it will finally call this particular function. If I comment this out, line out, then you will see that just importing this module will not execute the function. So if I just import this module and try to run this, we see no output because the function got declared, but it did not get executed. All right. Okay, moving on. Now, if you want to detect whether you have been run as a module or whether you have been imported, how will we do that? Well, very simple. We already know that if our Dunder name is equal to Dunder main, right? If the value of this variable is this, then we have been executed. Otherwise, we have been imported. Yes. So this is why a lot of the times in Python code, you will see something like this. You will see something like this written out. If Dunder name equals to Dunder main, then you will actually call some functions. So perhaps you will call the main function over here. So def main code print code is being executed. Right? So let me quickly come over here. Let me try to run example.py. Let me try to execute example.py. And over here, we see that, yes, we get the output code is being executed. Why does this happen? So the interpreter starts from the top. The interpreter tries to run this line. When it runs this line, a function is declared. After that, it will run this line. It will check if the Dunder name variable is actually equal to Dunder main. Yes, it is, because we have executed the module. And then it will finally call the main function, which will print this particular line. On the other hand, if I try to import this module, so let me create one more file over here. Let me create a file called importer.py. Right? And inside this importer.py, if I try to import example, and if I try to run importer.py, I will see nothing will be printed out. Because just by importing example, I am not calling the main function. Remember that when inside importer, when I import example, then this Dunder name variable for the main function will contain example. It will not contain this Dunder main value. So this code will not be executed. This function will not be called. Right? Now you understand basically why you see this kind of line in Python code if Dunder name equals to Dunder main. All right, and this is a very common pattern that you will see in Python codes. Perfect. Let us move on then. So far we have been talking about different files, but these files in Python, the correct term for them is modules. And so every .py file is a module in itself. Now we can go ahead from modules to packages. So there's something called packages in Python as well. What we can do is if we want to structure our particular program as nested directories, right? Or if we want to make sure that we are in different namespaces, what we can come over here and do is we can nest our code into further directories. So let me give you an example. So currently, this is what the code looks like. This is what my directory looks like. So this is the current directory. Right? Inside this, I have an example.py, I have an importer.py, and I have a some module.py. Now let me create another directory inside this. So mkdir package, right? And I'm going to, so now if I look at it, I will see that a package directory has been created. Inside this, currently there are no files. Let me create a file inside that. Let me create a file inside that. And let me say inside package or package module. Let me call this package module.py. All right, perfect. So let me quickly show you the tree once again. So we have example.py, we have importer.py, then we have a directory package. Inside the package directory, we have a package module.py, and once again outside we have some module.py. All right, now let us go to importer and let us try to import package module. Let us try to import package module. Okay. Let us try to import package module. Let us see what happens. Let us try to run Python 3 importer.py, and we get an error. We get an error saying that, hey, there was no package named package module. So what really happens is when you try to import it, Python will try to look in this same directory. I mean, the actual thing that is happening is much more complicated. But what you can understand for now is Python is trying to look in this same directory. In this same directory, there is no file called package module.py. Why is there no file? Because that file is inside another directory. It is inside another directory. So I can't import it like package module. What I have to do is I have to give the name of the outer directory as well. I have to give the name of the package as well. So I can say something like package.package module. Now what Python will do is it will go inside this Python directory and then look for the package module. So if I run this, I get nothing back. Basically, the code executes successfully. All right. Perfect. Now you don't really need to understand it right now. You don't really need to know it right now. But I just want to introduce one more concept. In packages, you often will see files like Dunder init. Right. So once again, we see this double underscore pattern over here. Dunder init is a file that is executed whenever you import a package. Right. So if I say print hello, over here, and if I come to the importer, let me quickly open the importer file once again. If I come to the importer and if I try to import package, then if we run this file, we will see that hello is printed out. The reason hello is printed out is because whenever Python imports a package, if this file exists, if the __init__.py file exists, Python will execute that. Okay, this file will initialize the module for us. Is that clear? Now there's a lot more to packages and modules and namespaces in Python. We are not going to go into so much depth because that is basically beyond the scope of what we can cover in 1 hour. Right? If you want to learn more about it, feel free to go to python.org, and over there you will be able to go through a tutorial that will give you all the insights and all the in-depth information of how packages and modules work. Perfect. Now let us quickly switch our gears from packages and modules to something called virtual environments. So I'm not sure how many of you are familiar with this, but just like on your system, you can install different softwares. Just like that, with Python, you can install different libraries. Right? So for example, if I come over here and I execute Python 3, if I try to import a library, something like matplotlib, this is a library that helps with drawing charts, that helps with some numerical or some graphical data visualization. If I try to import matplotlib, it is telling me that no module named matplotlib exists. Right, so this library is not available to Python at the moment. Similarly, if I try to import tqdm, perhaps this gets imported because tqdm is installed currently on my system. Right, now let me quickly show you where these values are, where these things are installed, and how to install a particular library. So if you want to see what all libraries are currently installed with your Python, you can do something like pip3 list. And this will give you a list of all the things that you have installed on your system currently, along with this Python. Right, so in this, you will see that tqdm has been installed. So this thing called tqdm, this library called tqdm is installed on my system, which is why I could import it. Right? But nothing like matplotlib exists on my system. Right? There's no matplotlib installed on my system, which is why I cannot import it. If I want to install this, I have to say something like pip3 install and then the name of the package. So matplotlib. So if I do this, this matplotlib library will be downloaded from the internet and it will be installed on my system. It might take some time, So now it is completely installed. Now if I go back to Python 3, and now if I try to run import matplotlib, this will work perfectly fine. Is that clear? So once again, to install a package, install a library, we have to do pip3 install the name of the library, right? And if we want to see what things are installed along with Python, what libraries are installed with Python, we can do something like pip3 list. All right, perfect. Now this is usually what we will usually never do this. This is a very, very bad practice. Currently, what I'm doing is I am looking at the global Python installation on my system. Right. So just like we saw that we were executing this Python 3. Right. So this Python 3 was installed in user bin Python. This is the global installation of Python on my system. Now, when we deal with larger projects, dependency management becomes a challenge. Right? The term is dependency management. That becomes a challenge because some projects might be using a different version of a library, while other project might be using a different version of that same library. Also, managing for a particular project, suppose that you are going to ship your product, right? You are going to give your project to a friend. How does your friend know what all libraries they have to install to make sure that your project works? Right? So basically managing all the dependencies of your project, that is something that we call dependency management. And for dependency management, to keep in mind that dependency management is necessary for us, we never install things in the global Python installation. Instead of that, what we do is we create something called virtual environments. Right? So to create virtual environment, first what you will have to do is you will have to install sudo apt install python 3 virtual env. Right, so the command over here is sudo apt install python 3 virtual env. Right, now this is if you are working on Linux like systems. So if you are on Mac OS, you will have to probably do brew install python 3 virtual env. If you are on Windows, you will have to I think the default installation of Python that you get, the default exe that you get to install Python automatically installs the virtual environment. All right. So if I hit enter over here, currently it is already installed on my system. So it will ask me for my password. I will quickly enter my password, and it is already installed on my system. So it will not really install anything new. But on your system, if it is not installed, it will download and install this package. Now, once this package is installed, we can come over here and we can specify something like virtual env. If I run this command, I will get a large output back. Notice that I'm getting an output back and not an error back. Right? I'm getting an output that is telling me that, okay, you're supposed to pass some extra parameters to this command, which you have not passed. Now, we will be using this virtual environment command to manage our Python installations, not really Python installations. We will be using this to manage the virtual environments. Okay, so bear with me over here. Let us run a quick command first. What we are going to do is we are going to do virtual env -p. So -p stands for the Python installation over here. And we are going to specify the path to our Python installation. So user lib python 3. Right? After that, we are going to also give it a directory name. So let me give it a directory name called vn. Okay, so what this is going to do is it is going to create a virtual Python installation. It is going to create a virtual Python installation inside this directory vn, right? And that virtual Python installation will be a copy. Right? It will refer to this Python. It will use this Python executable. So as soon as I hit enter, interesting, user lib python 3. Let me quickly see which python 3. Okay, it's not user lib python 3, it's user bin python 3. Right, so my bad, I entered the path incorrectly. So it is user bin python 3. When I hit enter, it will create a virtual environment. So notice that the output says created virtual environment using this C Python, right? Using the Python 3.8 interpreter. Apart from that, it also tells me several other things. It tells me that these all things have been installed. Right? These all things have been installed. So let us quickly see what our directory looks like now. A new directory called vn has been created. All right, a new directory called vn has been created. And if I try to do a tree in this, I will see that inside this vn directory, there are lots and lots of things. Right, so inside this vn directory, there are tons and tons of things. Inside this VM, there's a bin in which we have several files over here. There's a lib in which we have tons of other files over here. Right? So this is a virtual. This is an isolated Python environment that has been installed for you. Right? Now it is not activated yet. So for example, if I do Python 3, if I try to run Python 3 right now, the Python 3 will be executed from this location. Right? That is not going to help me. To activate this environment, what I have to do is I have to enter something like this. I have to say, so notice that this is the name of the virtual environment. I have to say source venv bin activate. Right? So inside this vn folder, there's a directory called bin. Right? Bin stands for binary. Inside this bin directory, there's a file. There's an executable file called activate. So what I have to do is I have to execute that file, and I have to basically source it in my terminal. Right? That will make sure that whatever exports, whatever things the file has changed, whatever environment variables that file has changed, my current terminal takes them over. Right? So if I execute this, two things will happen. So first of all, you will see your prompt has changed. Right? So earlier my prompt said Pragy Agarwal. Now notice that my prompt is saying Pragy Agarwal, and it is also showing me that I am currently working in this VM. Right? I'm currently working in this VM. The second thing that has happened is your virtual environment has gotten activated. So now if I look at which Python 3 will be run, if I try to execute Python 3, instead of getting that user bin Python 3, the Python 3 that now will be executed will be inside this VM. Right? So this is my home folder. This is my home folder. Inside this, I have this directory, project organization. In that, I have created this virtual environment. And in that, inside bin and Python, there's a Python installation. So if I try to run Python 3 now, this Python installation is called. Now in this Python installation, by default, there is no library installed. So if I try to import pqdm, it gives me an error. If I try to import matplotlib, it gives me an error. Notice that in the default Python installation, all these libraries were available, right? But in this new Python installation, these libraries are not available. So let me quickly exit, and let me also try to see by pip3 list. Let me see what libraries have been installed. And in these libraries, these are some default libraries that will automatically be installed, right? But anything like tqdm, matplotlib has not been installed. All right. So currently I'm working in an isolated Python environment. If I want to install something, suppose I install tqdm in over here, pip install tqdm, my bad. This tqdm library will be installed in this current virtual environment. Right? As long as this virtual environment is activated, this tqdm library will be installed in this virtual environment. Now, if I do pip list, now I will see that tqdm has been installed. All right, and the nice thing is that whatever packages, whatever libraries I install in this virtual environment, they will remain in this virtual environment. It will not affect any other virtual environment, or it will also not affect my global installation of Python. Right? So that basically allows us to isolate our dependencies, to isolate our project and libraries. Okay. So currently the virtual environment is activated. If I want to get out of the virtual environment, I have to enter the command deactivate. Notice that this command will work only when the virtual environment is activated. If you try to execute this command otherwise, so currently I'm out of this virtual environment, you know that because my prompt has changed back. Right? My prompt has changed, gone from virtual environment back to just Pragy Agarwal. Right? So if I try to run this command now, it will give me an error. It will say that, okay, deactivate command not work. This command will only work when you are actually inside the virtual environment, when you have actually activated the virtual environment. Now, if I try to run with Python 3 again, I will see that I will get user bin Python 3. Okay. Very quickly, once again, if I do source venv bin activate, and now if I run with Python 3, once again, my Python installation has changed. And to deactivate, I can do deactivate. All right. Perfect. Yes, this is so. Pratham has a very nice point over here. Pratham is saying that this is like an incognito mode for Python. Pratham is saying that this is like an incognito mode for Python. Exactly. All right. Perfect. So I want to leave you with this over here with respect to the virtual environments. There's a lot more to working with virtual environments, managing dependencies, right? Installing and shipping dependencies to other people, right? There are things like Docker. There are several other things that that you use as a seasoned software developer. But we are not going to discuss all of that today. If you want to learn more about that, feel free to go to, once again, python.org, and you will be able to get much more information over there. All right. Now let us quickly switch gears once again, and let us go back to the data structures that we have been discussing. Okay. So let me quickly go back, and let me create a new file over here, and let me save this as datastructures.py. And let me save this in the Python organization folder. Perfect. So far in the last class, we have discussed about the most basic data structure, which is a list in Python. Yes, does everyone remember how to create a list? So if I want to create a list with the numbers 1, 2, 3, and 4, I can say my list, or something like my list equals to, and what is the syntax? This square brackets, right? 1, 2, 3, and 4. Right, now I can come over here and print my list. So if I try to execute this, Python 3 or ds.py, if I try to execute this, I will get that list printed out. Right? If I want to create a list of all the numbers from 1 to 1000, how can I do that? If I want to create a list from 1 to 1000, then how can I do that? Will I have to type everything one by one? Not really, right? I can use this range function that we have discussed. So this range function takes three parameters: the start, the end. Notice that this end will be excluded. So 1001 will not be part of my result. And the step, right? So it will increment and steps of one. So if I say my list 2 equals to range 101, if I try to print my list 2, I will get a weird output. Right? If I try to print this, I will get a really weird output. It will say that my list 2 is range 1 to 1001. Right? It doesn't really give me the list. If I want to create a list, I will have to explicitly convert it into a list. The reason is that this range function gives you back a range object, which is sort of a lazy object in Python. Now you don't have to worry about what lazy and what eager competition right now is, but just understand that this range function, when you call this range function, it will give you back a range object. If you want to actually see what's in this range object, you have to convert this into a list explicitly. So if I try to execute it now, this huge list will be printed out. All right. Perfect. So this was the basics about lists. Yesterday, we also saw how to index into lists, how to find things from lists, and so on and so forth. Right? Today, let us talk about some other data structures. So let us talk about tuples. Tuples are very much like lists. Right? So tuples are almost exactly like lists. There's one crucial difference between tuples and lists, though. The difference is that lists are mutable. Basically, once you have created a list, you can change it. On the other hand, tuples are immutable. Once you have created a tuple, you are not allowed to change it. It is not changeable, right? You can't change it. You can definitely create a new tuple. You can definitely come and create a new tuple, but if you have already created a tuple, you cannot change it, right? So let us look at an example. Just like this list has the syntax of square brackets, just like that, a tuple has a syntax of round brackets. Right? So I can come over here and I can say my tuple equals to 1, 2, 3. Right? So this will be a tuple and I can print my tuple. Right? So let me remove this huge list from here so that we don't clutter our terminal. So if I run this, I will see that the list has been printed and this tuple has been printed. All right. Now let me quickly show the difference between lists and tuples. So if I try to change this list, my list of, let's say, 0. If I take this first element, I can change it to something like 100. If I run this, then after this has changed, my list will be, the first element of my list will be 100. But if I try to do the same for the tuple, if I try to do my tuple 0 equals to 100, then let us quickly see what happens. When we try to execute this line, we got an error. The error said tuple object does not support item assignment. Basically, for any index in the tuple, you can't assign a value to it. You can't change the value. All right. So tuples are immutable. Is that clear? Perfect. Now, if you want to create a list that has just one item in it, suppose the number 1, then how do you do it? You can simply come over here and say my list equals to 1. Yes, you can come over here and say my list equals to 1. Right? So this will give you the list just 1. But what if you want to create a tuple with just one value in it? My tuple. Will this work? Well, let us quickly see what happens. When we execute this. We get a list back, but this just looks like the number 1, right? This just looks like the number 1. In fact, if you print the type of my tuple over here, then we will see that it is not a tuple at all. It is an integer. The reason is that this bracket notation, right, this round bracket is also used to club expressions. Right? These brackets are also used to club expressions together. So to distinguish a tuple with one element with just the number one, what we have to do is we have to have a leading comma over here. We have to end it with a comma. Now if I try to execute this, this tuple will actually be printed, and you will see that the type is now tuple. All right. Perfect. So tuples are exactly like lists. It is just that tuples cannot be mutated. So whenever you are looking for a list that others cannot change, you will use a tuple. Other than that, the indexing and everything else remains exactly the same. Now, once again, when you were creating a large list, you could say my list equals to list of range of 100, and that will give you a list of 100 elements. If you want to do the same with a tuple, you can say tuple of range of 100. This will give you a tuple of 100 elements. Right? So firstly, we get a list of 100 elements, then we get a tuple of 100 elements. This is a tuple because it is delimited by these brackets, by these round brackets and not the square brackets. Okay. Prakash is asking why this extra comma is there. Right? So back when we did this, my tuple equals to this. Right? Why did we have to include this extra comma? Right? That is the question. So let me quickly once again answer it. So suppose that we are doing something like 1 times 2 plus 3. Right? Suppose that we are doing 1 times 2 plus 3. We've all studied BOD-MAS. Right? We have all studied BOD-MAS or PEG-MAS, whatever you call it. So what will be the order of these operations? Multiplication has higher precedence than addition. Right? Multiplication has higher precedence than addition. So 1 times 2 will be executed first, then 3 will be added. So the result over here will be 5. If I want to override that, if I want to say that, no, please execute this thing first. Right? If I want to say, please execute, let me make this 10 perhaps. Right? So the current result will be 23. If I want to execute this thing first, then I will have to explicitly put this in brackets. Yes, I will have to explicitly put this in brackets. Well, this will give me the answer 50. Well, what if I do something like this? What if I do something like this? This is just saying take the number 1 and this number 1 is in brackets. Right? This number 1 is in brackets. So basically we are not really doing anything. Right? I could come over here, I could write 1 plus 3. 1 plus 2 is the same as this 1 plus 2. Right? So these brackets are not really doing anything. These brackets will be completely ignored. Now we want a tuple over here. Right? By these brackets, we are not seeing the mathematical expression 1. We want to specify a tuple, and to distinguish the syntax between a mathematical expression and a tuple, we have to give an extra comma at the end. All right. Perfect. Cool. So this was very briefly about tuples. You will use tuples whenever you want to use a list, but you want the list to be immutable. Let us quickly move on to something called sets. All right. So if you have heard of sets, set is nothing but just a collection of objects. Right? A set, mathematically, a set is just a collection of things. Right? In Python, sets mean a little differently. So sets, once again, they still are a collection of things, but they have some other properties associated with them. The most important property is that sets are implemented as hash sets. Right? So if you're not familiar with what hashing is or how hash table works, don't worry about it right now. When you actually take a data structures and algorithms course, you will be able to understand how hashes work and how hash sets work, right? And why they are important. But for those of you who are familiar with it, Python sets are implemented as hashes, which means that a lot of the operations, indexing into it, checking if a value is there or not, inserting and deleting into it, not indexing, inserting, deleting, and checking if a value is there, they are amortized constant time operations. Right? Now to create a set, we have a different notation. So once again, this is for a list. This is for a tuple. For set, we have to use this notation. This notation is for a set. All right. So let us quickly see how sets work. So I will say that my set equals to 1, 2, 3, and this will create a set. If I try to print out my set, let's quickly see what gets printed out. So 1, 2, 3 has been printed out. Let me just remove this thing. Let me just remove the previous code over here. Right. So this 1, 2, 3 will get printed out. Okay. Now, just like list supports a lot of different operations, sets also support a lot of different operations. To actually see what all operations sets support, what you can do is you can go inside your Python REPL. You can go inside your Python REPL and you can type help set, right? And it will tell you all the different things that set supports. So it will tell you that, okay, this class has many different methods. So some of these are called magic methods. These methods that start and end with underscore, these are called magic methods in Python, right? But apart from that, it has some methods like add, clear, copy, set difference, difference update, and so on and so forth, right? Set intersection, checking disjoint, checking subset, and so on and so forth. All right. So very simply, if you want to insert something into a set, you will say my set dot add, let's say the value 10. And now if I print my set, the value 10 will be included in the set, right? So the value 10 is included in the set. Now notice the thing that when I added the value 10, the value was added towards the front, right? The value was added towards the front. It was not added towards the end, which is surprising, right? If I try to add perhaps another value, so let us say that I try to add the value 123, right? This some random value. And if I try to print it once again, now the 10 has been added after 3. In the previous run, the 10 was added before 1. Now it has been added after 3. That's weird, right? So the point over here is sets are always unordered. Sets are unordered. You can never ever rely on which order the elements will come out in. When you insert something into a set, the set tries to ignore the order. It does not try to remember the order, which is why it can do some operations much more quickly. Right? So if you want the order to be preserved, don't use something like a set. Instead, use something like a list or a tuple. All right. So sets will always be unordered. The order can change arbitrarily. All right. Perfect. Now let me quickly show you why sets are so powerful. So suppose that I have a list, my list. So let me erase everything. Let me create my list, and I have a very large list. Right. So I have a list of all the numbers from, let us say, 1 to 1 million, right? 100,000 and 1 million. Right? This is my list. If I try to find if a particular element is in my list, then how should I do it? How should I do it? I can do something like print some element like 9999 in my list, right? Or perhaps 99999 in my list. Yes, I can come over here and do something like this. So let me run this code, and we quickly get the answer true, right? We quickly get the answer true. Let me try to increase this value, right? Let me try to increase this value. Let me define an n, or not int n. I will just say n equals to 100,000, 100, right? So suppose this is my n, because basically 10 million right now, 10 million, right? And let me define the number value equals to n minus 1, right? Or let me just write it over here. So I will check if n minus 1 is inside the list. Because I'm creating a list of all the numbers from 0 to n, excluding n minus 1 will be in my list, right? So I should always get true back. Let me try to run this once again. It took some time, right? It didn't execute immediately. It took some time. Let me add one more value over here. Let me add one more 0 over here. Let me see how much time this takes now. So it is taking much more time. Right? It is taking much more time. So the reason it is taking time right now is because it has to do a lot of memory allocation. Right? The time currently is not just constrained by this operation, by just checking. It is also constrained by the time it has to spend to create this particular memory. So instead of doing this, let us create a smaller list. Let us create a list of just 1,000 items. Let us just create a list of 1,000 items. But let us do this thing again and again. Let us do this loop again and again. So I will do for underscore in range 1,000 or 10,000. I will do this thing 10,000 times. Right? N minus 1 in my list. It will just check if n minus 1 is present in my list or not, and it will do that 10,000 times, right? And finally, I can print done, right? So let us see how much time this currently takes. Let us see how much time this currently takes. It was done very quickly. Right? Let me try to increase the number of iterations. Let me try to increase the number of iterations, and now we see that this takes a very long time. Right? Now this takes a very long time. The reason is that in lists, if we have to find a particular value, if you have to search for a particular value, that searching is linear time. Right? That searching is linear time. On the other hand, if we are looking at sets, then the search is order of one time, amortized order of one time. It takes this constant time. So if I do this with a set, you will see that it gets done very quickly. Right. So once again, if I do this with a list, this will take a long amount of time. So it is taking several seconds, and finally it will be done in some time. It is taking quite some time. Now it is done. But if I switch this to a set instead of a list, if I use a set over here, then it will give me back the answer immediately. Right? Because checking if a value is present in a set is very fast. All right. Perfect. Now, just like we have sets, we have something called dictionaries. Right? So once again, this was used to denote list. This notation was used to denote tuple. This notation was used to denote set. Well, for the dictionaries also you have the same notation. This is also used to denote dictionaries. Right? Now, dictionaries are maps. Dictionaries are mappings. So dictionaries, they are not the dictionaries that we see, that we actually hold, right? They don't have word meanings. These dictionaries are mappings. So they have some key and they have some value. For example, I can come over here and say my dictionary, or let us say squares of numbers, right, equals to, and now I have to use a different kind of syntax over here. I have to use a key colon value syntax, right? So I can say that the square of 1 is 1. Then I can say the square of 2 is 4. I can say the square of 3 is 9. I can say the square of 4 is 16, and so on. Okay, so basically what I'm saying over here is that if you look at the square of 1, that value is 1. Right? If you look at the square of 1, that value is 1. Now, how do I get the square of a particular number? If I want to get the square of 3, I can do something like squares of numbers, and now I can give it a key. So these things on the left of column, all the things on the left of column, these are keys. All the things on the right of column, these are values. If I give it some key, if the key exists in my dictionary, then this will pull out the value. Right? This will pull out the value. So if I just try to print this, we will see 9 getting printed out. Right? We will see. I guess I misspelled the name. Right? We will see 9 getting printed out. All right. So dictionaries are very powerful if you want to store mappings, if you want to store a key value pair. Now, just like sets, dictionaries in Python are also implemented using something called hash tables, which is why the indexing, or not the indexing, basically the indexing, yes, in this case, the indexing is there. Indexing, searching in a dictionary, right? All these things are very, very quick. Inserting, deleting from a dictionary are very, very quick. All right. I suppose that we can end it at this point today. I wanted to go into much more depth of all these data structures, but unfortunately, we do not have the time. All right, so let us complete that some other time, and let us end the lecture with this. Okay, so once again, if you go into the video description, you will be able to find a link to some questionnaires. You will be able to find a link to a chat where you can basically go and discuss with your peers, with all the people who are watching on YouTube. You will also be able to discuss with the instructors. So I will also be present in the chat. If you have any questions, you can go over there and ask. So the links are in the video description. If you want to see the previous videos of this series, the links for that is also in the video description. All right. So I hope to see you the same time tomorrow. All right. So 6:30 p.m. to 7:30 p.m. tomorrow. And tomorrow we will be looking at some more advanced concepts of Python. Bye-bye.